Alright, in this section we're looking at the region of a circle, that is where inequalities are involved. Now we have seen how the locus of a circle can be sketched with the equation of a circle given in the previous section. Now we shall consider regions defined by inequalities which involve circles. Now let's take a look at example 30a. Now in example 30a, you are asked to sketch the set of points satisfying this inequality. The inequality concerned is z minus 1 plus I less than or equals to 4. Now let's recap. Now the variable complex number z, alright, is represented by the point P, whereas the fixed complex number 1 plus I is represented at point A. Now when we have this in this form, we are actually saying that the distance from the point P to the point A is always less than or equals to 4. No, previously if we have the equation as equals to 4, that means we are saying that the distance from the point P to the point A is always equals to 4. But in this 30 part A, we are saying that the distance from point P to point A, alright, is always either 4 or less. Right? So what does it mean? Okay, what it means is very simple. You need to draw the circle first, the imaginary and the real. Alright, the center of the circle, we're already quite familiar with this, is actually 1 1. So 1 here, 1 here, so this is the center of the circle, 1 1. Alright, and the radius is 4. Alright, so drawing the circle properly, the radius is in this form. Alright, okay, so what are the points that satisfy this inequality? Now let me just take a point on the circumference of this circle, this point. Alright, so this point is the point P, and we know that according to this equation, the distance from the point P and the point A, which is the center of this circle, must be equals to 4. Right, equals to 4. Yeah. Now can I choose a particular point here and then say that this is a point P? I can't, because then the distance from here to here is no longer less than or equals to 4. Alright, so it seems to be saying that the region outside the circle is unwanted. Right. However, if I were to choose a point P which is inside the circle, and I measure the distance, and this distance is obviously less than 4, and it satisfies the equation. So the solution for this particular part, alright, where we have the inequality, is actually everything inside the circle. Right. So the answer for this question is you plot the circle plus shading everything which is inside. So this will be the solution, alright, for this particular inequality. So every point on the circle and inside the circle actually represent the complex number z, and in this case is represented by the points P on the Argand diagram. So just to make sure that you don't get confused, I will erase this particular point P, which is outside, which is not wanted. Alright, so your point P are everything on the circle, that means on the circumference, as well as inside the circle. Now let's take a look at the example in part B. Now in part B, again, you notice that this is not of the standard form. Right, so automatically you know that you need to change it into the standard form in this case. Alright, so let's draw. Now, so you have the imaginary, you have the real, The center is -1, -1, so the center is here. -1, -1, and usually we call this the point A, right? Because this is point A and Z is represented by the point P. Okay, so I want to find point Z such that the distance from P to A is always less than 4. That means, right, when you draw this circle, you cannot draw the circumference of the circle using a full line. Alright, it must be a dotted line. Okay, because a dotted line will show that all the points on the circumference are actually unwanted points. Okay, so let's draw. Again, right, I'm using a free hand. Alright, so my circle is not very pleasing to the eye. Alright, so you should remember to always use a compass. Right, so if I were to mark this distance, alright, this distance is always 4. Now let's check again. If I were to choose a point outside, you already know any point outside is not wanted. Why? Because the distance from A to P is not less than 4. Now how about if I were to choose a point which is on the circle, like so? Alright, now this distance is obvious. The distance between the point P and A is 4. Does it satisfy the equation? No, because the equation actually says less than 4. So that is why we cannot include the point on the circumference of the circle. So what is the end result of this inequality? Alright, so the point Z are all the points which you can actually find inside the circle, but not on the circle, inside the circle. Alright, so when you represent this answer, you should present a dotted circle with everything inside shaded like so. Let's take a look at example C. Now example C, there are double inequalities on both sides of the modulus. Alright, so we again as quickly as possible write the equation of the circle in the standard form, and we realize that it seems to be saying the distance from the point P to the point A is always between 1 inclusive but less than 2. Example 30 part C. Alright, we need to write it again in the standard form. Okay, but in this case you actually see that we need to actually draw two circles. Okay, one of the circle is of radius 2 and the other circle is of radius 1. Alright, so let's start to draw this circle. Imaginary, real. The center is -1 and -2 here. Alright, this is the center. Okay, and we always label the center as A. Z is represented by the point P. So let's draw the bigger circle first, radius 2. Okay, now we know that on the right side of the inequality is a strictly less than, so we realize that we should actually use a dotted line. Okay, so dotted line with a radius 2. As you can see again, because I'm using freehand, my circle is not very pleasing to the eye. So be careful when you present your answer, make sure you draw using a compass. Then on the left side, we have the radius 1. So we need to draw a circle of radius 1. But on the left side, we realize that is less than or equals to. So this one we can draw using a full line. Alright, so this distance is 1 and this distance is Alright, so let's mark our point as A, and the center of this circle is actually negative 1, 2. Okay, so where are the points that satisfy this inequality? Alright, so we know that the distance from the point P to the point A must always be between 1 and 2. So you realize that the answer to this question is all the points in these parts. Right? It is very easy for you to check. Alright, you can just choose a point here, alright, as your Z, and then you connect with the center of the circle. You realize that this distance is always between 1 and 2.